In this video, we are going to discuss in detail about honing operation. You know that honing operation is performed using special tools called honing stones or horns. A honing stone is composed of abrasive grains bonded together using an adhesive. These abrasive grains are irregular shaped with approximate size about 50 micrometers. The honing stones perform similar operation as that of a grinding wheel. But honing stones are usually more friable. Friable in the sense they can be easily be crumbled. They will easily wear out and conform to the shape of the workpiece. Since honing stones are friable, to improve its life, honing stones are usually treated with wax and sulfur. As the grain size of abrasives in the honing stone decreases, the surface finish of the workpiece improves. Let us see how honing operation is performed in a horizontal honing process. Here you can see a honing tool with honing stones attached at the periphery of a spindle. These honing stones are held against the internal surface of the workpiece with controlled light pressure. The pressure is exerted with the help of small springs mounted in the honing tool. Let us discuss in detail about various honing stones which are used in a honing operation. The abrasive materials used in honing stones are corundum, silicon carbide, cubic boron nitride, diamond, etc. The honing stones are usually used with the help of a cutting fluid. The cutting fluid enables smooth cutting action in the honing operation. Honing stones are available in two types. One is natural stones, another is artificial stones. Artificial stones or synthetic stones are having superior performance when compared to natural stones because in artificial stones the particle size is consistent, the abrasive particle size is consistent, and there is better control over the properties of the honing stone. Therefore, synthetic stones or artificial stones are preferred over natural honing stones. Artificial stones usually come in the form of bonded abrasives, which composes ceramic such as silicon carbide, aluminum oxide, or corundum. Another name for silicon carbide is carborundum and aluminum oxide is corundum. Natural stones are typically formed of quartz. A typical quartz material is novaculite. Three commonly used honing stones are oil stones, water stones, and diamond stones. Let us discuss about each of them one by one. Oil stones are traditionally used Western honing stones. They are made up of one of these three material, novaculite, aluminum oxide, or silicon carbide. And oil stones are usually used along with oil supply because this supply of oil is used to remove the swarf or the excess material in the form of chips. Traditional oil stones are usually made from novaculate, while artificial oil stones are made from aluminum oxide. Silicon carbide oil stones are the fastest cutting oil stones. The main advantages of oil stones are they have good overall performance and their price is comparatively low. But the main disadvantage is that they have very slow cutting rate and the oil used along with these oil stones are difficult to get removed with water. Okay. Water stones are relatively a newer development when compared to oil stones. As the name implies, water stones are used along with water as the fluid which is used to remove the swarf or excess metal. The water stones are available in both natural as well as synthetic forms. Synthetic water stones are usually made of aluminum oxide. The main advantage of water stone is that they have faster cutting because these water stones are softer so that the old abrasive material can easily break away and they are getting replaced with fresh sharp abrasive material. So they promotes faster cutting operation. The main disadvantage of water stone is that they are softer so they easily wear out. So this will also get out of shape easily because they are softer. So in order to bring the honing stones back to its original condition, frequent flattening operation is required in between this honing operation. Next is diamond stone. Diamond stones usually contains small diamonds attached to the face of a metal plate. A figure is shown here. These small industrial diamonds are mostly harder than any other sharpening stones such as water stones and oil stones. The diamond stones are available in two forms. They are hole type diamond stones and continuous type diamond stones. The hole type diamond stones contains holes in the surface of the diamond in order to capture the excess metal or swarf. These stones are very faster in cutting operation and is very simple to use. Next is diamond stones with continuous surface. These stones are preferred for sharpening tools with sharp points. These stones have a continuous diamond surface and the surface is flat and there is no holes. So they can be used easily to sharpen tools with points. Okay. Both diamond stones are available with monocrystalline and polycrystalline diamonds. The monocrystalline diamonds have more life and they are more desirable in honing operation. The two great advantages of diamond stones are they have faster sharpening ability and the flatness of the stone, diamond stone will be retained for a long time. The diamond stones are so hard that they are used to flatten oil stones and water stones. But the main disadvantage of diamond stone is that it has higher initial cost. Even though they are expensive, they will last longer and they have more durability. Let us discuss about the conditions under which better honing operation can be performed. The important parameters which affect the material removal rate and surface roughness in a honing operation are the unit pressure P, that is the applied pressure per unit area, the peripheral honing speed, that is the peripheral rotational speed of the peripheral tangential speed of the honing tool, and the time for which the honing operation is performed, which is represented by T. In this graph, the material removal rate, which is represented by letter Q, and the surface finish, which is represented by R, are plotted against the unit pressure P. From the graph, it is clear that the unit pressure should be selected in such a way that there should be minimum surface roughness and higher possible material removal rate. An optimum value of unit pressure is shown in this graph. Here we can find that if the unit pressure is exceeding too much, the surface roughness increases along with increase in the material removal rate. Even though the material removal rate is increased, the surface finish will be affected. So you cannot increase the unit pressure too much. That will have undesirable effects. Next is the effect of peripheral honing speed, that is the tangential velocity of the honing tool. If this peripheral honing speed is increased, the material removal rate increases. At the same time, there will be a reduction in the surface roughness. So increasing the peripheral honing speed has more advantages. Figure 3.14 shows the plot of material removal rate and surface roughness for the honing time. The honing time is shown in the x-axis. As per this graph, if the honing time increases, if the honing operation time increases, the material removal rate decreases. Also, there is a chance for increase in the surface roughness. So, an optimum honing time should be selected. This is represented by tau dash. Let us discuss about some of the cutting fluids which are used in honing operation. The honing oil is one of the critical components which affect the honing operation. Selecting the right honing oil has direct as well as immediate impact on the abrasive consumption, the labor required, the honing cycle, number of honing cycles required, as well as the quality of the surface. Selecting a wrong honing oil will also increases the scrap cost. It will create workpieces with wrong tolerances and poor surface finish. Therefore, the success of a honing process depends upon 5 key components. They are the honing machine, the fixture used for holding the workpiece, the honing tool, the type of abrasives used in the honing tool, and finally the honing oil or the cutting fluid. To enhance the properties of honing oil, special lubricating agents and special additives are added to the honing oil. During honing operation, friction occurs between the honing stone as well as the workpiece surface. This will generate frictional heat, and the major problems associated with the frictional heat is the welding as well as the decreased abrasive life of honing tool. Therefore, honing oils and lubricants are used in the honing process. They wash away the chips and sarf from the surface of the workpiece during honing operation, and it also brings new abrasive particles to the surface of the stone. Thus, optimum abrasive cutting action is ensured during the honing operation. The honing fluid used in a honing operation should have anti-corrosive properties. It should not corrode the workpiece. It should also provide sufficient lubricity or sufficient lubrication even at higher temperatures and higher pressures. As I have already mentioned, during honing operation, in between the workpiece surface as well as the abrasive stone, the temperature rises. The temperature rises mainly due to frictional heat, and the temperature rises to such a level that it will reach up to the melting point of the workpiece getting honed. This will create microscopic weld between the honing tool as well as the workpiece surface. And this welding problem especially occurs with high alloy materials such as stainless steel. Therefore, the honing fluid used in a honing operation should carry away the heat generated during honing operation, as well as it should provide sufficient lubrication in between the surfaces. Usually, some high-performance anti-weld additives are added to the honing fluid, such as sulfur, chlorine, phosphorus, etc. Certain lubricity additives are also added to the honing oil, which will always keep the abrasive surface clean. There are various types of honing fluids available in the market. They include petroleum or organic oil-based honing fluids, super finishing fluids, synthetic and semi-synthetic water-based fluids, etc. Now we shall discuss about a new machining process called broaching. What is broaching? It is a metal removal process or a machining process using a specialized tool called broach. In a broaching tool, the teeth are arranged in successive rows. The position of the tooth in the successive row is higher than the tooth present in the previous row. Therefore, the tooth on successive rows provide more depth of cut. The main advantage of broaching operation is that the operation is faster so that a complete machined workpiece is obtained in a single stroke. Broaching can produce internal and external machined surface. The production rate is high as well as closer tolerances can also be obtained. For better understanding, let us go through a broaching operation video. Here the tool moves downwards and enlarges the size of the hole. The depth of cut produced by successive teeth is more. The broaching process uses a multi-point broaching tool, and this tool can be used for external broaching as well as internal broaching operation. External broaching removes the unwanted material from the surface of the workpiece, while internal broaching enhances the size of the hole. Different profiled holes can be produced as shown in this figure. In a broaching operation, the workpiece is stationary and the tool is fed in one direction. As seen in this figure, for a broaching tool, the height of the successive teeth are higher than the previous teeth so that it will produce more depth of cut. Gullets are special spacing provided in between the tooth for retaining the chips which are produced during the broaching operation. Therefore, the advantage of broaching operation is that in a single pass, the complete depth of cut can be achieved. A broaching machine is usually specified by maximum length of the cutting stroke, the maximum force developed, which is usually expressed in tons, the types of drives required for performing the broaching operation, the power rating of the electric motor, the speed and feed, weight of the machine, as well as the floor space required. Let us see what are the advantages and disadvantages of a broaching operation. In a broaching operation, the rough machining and finish machining can be completed in a single pass. The tooth which are located at the front produces rough machining and finish machining is obtained by the tooth which are secured at the back side of the broaching tool. The production rate is high, the cutting time is very low, and rapid loading and unloading of the workpiece is possible. Broaching tool can be used for machining internal and external surfaces. Broaching tools can also be produced with complex profiles so that workpieces can also be produced with the complex geometry. Closer tolerances can be obtained by using a broaching tool. The surface finish is equal to milling, and finally, the skill of operator required for broaching operation is less. Let us see what are the disadvantages of a broaching operation. The life of a broach tool is very less, therefore the tooling cost is high. In some cases, for low production rates, broaching operation is not economical. The force required for operating a broach tool is very high. Therefore, the parts to be broached should be strong enough to withstand these forces. And the surfaces to be broached are located in an accessible region. Let us discuss about different types of broaches and their applications. The broaching tools are basically classified into following types: internal broach and external broach, push type broach and pull type broach, ordinary cut and progressive type broaches, solid sectional and modular type broaches, profile sharpened or foam relieved type broaches. Let us discuss each of them. Internal broaches are used for enlarging and finishing various features of the holes present in objects made by casting, forging, rolling, drilling, punching, etc. These broaches are mainly intended for finishing through holes, non-circular holes, internal slots, internal keyways, splines, etc. They can be also used for finishing the teeth of spur gears. Internal broaches are available in two types, mainly push type and pull type also, and they are used for lighter operations. It has a set of teeth starting from roughing teeth, followed by semi-finishing teeth, and finally there will be some finishing teeth. In some broaches, few burnishing teeth are also added at the end. This figure shows the internal broaches which are used for various applications, especially for machining and finishing various holes. Holes with different features. We can find here holes with rectangular shape, double cut shape, and it is also used for internal gears, round holes, holes with helical grooves, hexagonal shaped holes, four splined holes, double keyways present in holes, single keyway, etc. The profile of the hole formed as well as the type of the broach used is shown in this figure. Next is external broaching. The external broaching is similar to that of milling, shaping, planing, etc., where the outer layers of the workpiece material will be removed. But this type of broaches provides better productivity and better product quality. These external broaches are available in the form of push type and pull type broaches, and major applications include unobstructed outside surfacing like flattening, as well as machining peripheral surfaces, contour surfaces, etc. These external broaches can also be used for cutting grooves, slots, keyways on the outer surfaces of objects. They can be used for making external splines of different forms, and they can be also used for external gear cutting operation, especially in spur gears and gear sectors. External broaches are usually made in segments and they are clamped to fixtures for various operations. Next classification is push type broaches and pull type broaches. What are they? Pull type broaches are those which are subjected to tensile force at the one end, and this will help for maintaining alignment during the machining operation, as well as applying a tensile force on one end of the broach will prevent buckling of the broach. Therefore, in pull type broaches, you are pulling the broach from one end. The machining of the workpiece happens just behind the pulled end. Since pull type broaches do not buckle, they are available in long single pieces and they are widely used for internal broaching operations. Push type broaches are those broaches which are pushed from the back end, so that machining happens in the front and the Pushing force is applied at the end of the broach. Since there are chances of buckling in push-type broaches, they are shorter in length and they are usually available in the form of small segments. Push-type broaches are generally used for external broaching whenever light machining and small depth of cut is required. Next is ordinary cut broach and progressive type broaches. In ordinary cut broaches, the height of the teeth increases from one row to the another. Means in successive rows, the height of the teeth increases. But in progressive cut type broaches, the width of the tooth is increasing. Single and double strip progressive cut type broaches are shown in this figure. Next is solid, sectional and module type broaches. The pull type broaches, which are used for internal broaching, are commonly single pieces or solid type broaches. But sectional broaches are also available. They are made by assembling several sections of cutter pieces in series. This will give convenience in manufacturing these cutter pieces as well as it is easy to resharpen them. External broaches are often made by combining a number of segments or modules. In sectional broaches, each tooth is an individual piece, but in segmented broaches, a series of tooth form one segment. Next is profile sharpened and form relieved type broaches. Profile sharpened type broaches are cutters with simple geometry having same rake angle and clearance angle all over the cutting edge. They are commonly used for machining flat surfaces as well as circular holes. That means surfaces with less complex geometry. Form relieved type broaches are commonly used for non-uniform profiles like gear cutting. Here the cutting edge geometry is more complex and the geometry varies from point to point along the cutting edge. The grinding method for profile sharpened type broaches and form relieved type broaches are different. Next we shall discuss about broaching forces. The force required for cutting operation in a broaching process is extremely high because the complete operation is carried out in one stroke or the finished workpiece is produced in one stroke of the broaching tool. Therefore, the maximum force required for broaching is very significant in determining the capability of the equipment that is used for broaching operation. How can we calculate the cutting force in broaching? In a broaching operation, the number of teeth actively engaged in simultaneous cutting operation is always constant. How can we determine this value? Or how can we determine the number of teeth that are actively engaged in cutting? It can be obtained by dividing the length of the workpiece to be broached divided by the pitch of the teeth. So N is given by length of the workpiece to be broached L divided by the pitch P. Next, how can we determine the maximum force required for broaching operation? The maximum force can be determined by taking the product of the specific resistance of cutting and the area of material removed and the number of teeth. Here the force is given as kilogram. The specific resistance of cutting is the force required for removing unit area of the material. It is always multiplied with the area of material removed. Once the specific resistance of cutting is determined for one tooth, it is multiplied with number of tooth required for cutting. This will give the maximum force required for cutting operation in a broaching process. Thank you.